Hi everyone, welcome to Chemistry Insight. In this particular video, I am going to discuss about rules for nomenclature of alicyclic compounds. That is, with suppose a ring structure is there. Here I will be taking cyclopropane, but how to write the name cyclopropane? Actually, here we can count that the first rule will tell we have to add a prefix that is cyclo prefix we have to use, and normal, what is the number of carbon over here, that is 1 2 and 3 is there. If suppose it is there in normal chain, like suppose like this, how many carbon is there? 3 carbon is there. We will add propane for this, correct? We will write propane. Since here it is cyclic in structure, we have to add cyclo as the prefix. That's why we will get it as cyclopropane as the IUPAC nomenclature. Suppose 4 carbon is there. Suppose like this. Correct? Like this, if it is there, it contains 4 carbon. Since 4 carbon is there, generally we will write butane for 4 carbon without unsaturation. Since it is cyclic in structure, we will write cyclobutane. Cyclobutane is the IUPAC nomenclature for this type of compound. Suppose if the second rule will state, if any substituent is there, one substituent is there, either it can be double bond or it can be any other substituent like methyl, ethyl, like that. Here I will be taking one example. What we have to do is, I will tell, suppose one double bond is there. As it is in the above case, what we done is just we added cyclo to the normal chain, correct? Here also the cyclic structure is there with one unsaturation is there, means here we have to write pentene, correct? Last we have to observe that primary suffix for double bond, if it is there, it has to end with ene. That's why here I have written cyclopentene. Here there is no need of mentioning like one cyclopentene like that. If one substituent is there, there is no need of adding one, because it understood that we have to start numbering from here like this. 5, either anti-clockwise or clockwise, both the one and the same. That's why here only cyclopentene we can write. And the other example I will be taking over here like this. It is like 6 carbon atom is there, and here I will be writing CH3. From where number has to start? The ring, I have to give the number from here, correct? The substituent is attached at this particular position, 1 2 3 4 5 6, like that. Total 6 carbon is there and methyl is there. Generally we have to write it as methyl hexane, methyl cyclohexane. Since it is cyclic in structure, we have to write cyclohexane, correct? Here also C, I have to write it as small with lower cap, correct? Methyl cyclohexane. Here I didn't mention that one methyl cyclohexane like that, because it understood that always numbering has to done where the substituent is attached. That's why this is the nomenclature. Only methyl cyclohexane is the nomenclature of this particular compound. We will move on to the next thing. Suppose here we can see that, okay, this one, the third rule will tell that if two substituent is attached with two different substituent, correct? Here this is methyl group is there which start with M, correct? Here ethyl is there which start from E. Between these two, alphabetical order has to be carried out, and we have to number in such a way that the locants has to get the lowest priority. That's why here E is there, E will come in alphabetical order. That's why I will give 1 2 and 3 like this. Now I can give number from this like this also, but since M will come later in alphabetical order, therefore from E I have to start like this. What is the, we'll start about naming of this particular compound. At the one position ethyl is there, That's why 1 hyphen ethyl, 1 ethyl, again hyphen, here third position 3 methyl. Only E should be caps over here. All like lower caps should be used. Methyl, and what is the name of this particular? It contains 6 carbon atom, and hexane will come since it is cyclic in structure. We have to write cyclohexane. Cyclohexane. This is the IUPAC nomenclature for this particular compound. Then we'll move on to the next thing, which include double bond over here. Here we have to give a number in such a way that carbon-carbon double bond has to get the least number. That's why I have to start from here. 1, 2, 3 and 4. Correct? In this case, we have to locate the position of this double bond as well as this methyl and this ethyl. Now we'll start writing this particular one. Since ethyl is there, E will come in alphabetical order first. We have to write this substituent in the first order. That's why here I will write 4, then ethyl. 4 ethyl is there, and the second position we have methyl. Correct? Again hyphen 2, again hyphen, and here methyl. Then what is this structure called as? This is cyclohexene. Correct? The double bond will be located at carbon number 1. That's why we have to write cyclohex hyphen we have to use over here at the position 1 and ene. This is the IUPAC nomenclature for this particular compound. Then we'll move on to the next thing like this. Here the two methyl groups are there at same carbon atom and one ethyl group is there at different. In this case, what we have to do, in if only one methyl is there, we have to start numbering from this side. Here there are two methyl groups, that's why we have to start from here. 1, 2, 3. Now if we count the locants of this particular one, we will get here 1 plus 1 and here 3 is there, 3. Total we will get it as 5. Suppose from here if I start 1, 2, 3 like that, here only one ethyl is there, 1 plus here 3 plus 3. Correct? Total it will become 7. That's why lowest set of locants we have to follow. That's why we have given the correct order like this, 1, 2, 3 like this. Now we'll start naming of this particular compound. First we have to name this particular one because E will come in alphabetical order first. That's why here 3 ethyl, then hyphen, here 1 comma 1, at the same position two groups are attached, 1 comma 1 and dimethyl. This all the substituent we already named and the remaining is cyclohexane. Here cyclohexane. This is the IUPAC name. Then we'll move on to the next thing, the rule 4. Here we have generally like carbon chain like this. Carbon chain we will get as a substituent, and at the other side we will get a ring like this. This is not actually ring, it can contains like 3, 4, 5 like that. In this case we have to identify the first thing is parent chain, and which one is the substituent, and the second one is substituent. Correct? We have to identify these two. Here we have the ring also and there is a chain also. Between these two, which one is substituent and which one is the parent chain? This one, the rule 4 will tell that if suppose a ring contains less number of carbon atoms compared to the side chain attached to that, because this long chain, if suppose here we have only 5 carbon, here if we count 1, 2, 3, 4, 5, 6 is there. Here the carbon atom is more in number compared to the carbon atom in this particular ring. That's why we have to take this longest chain as the principal chain, that is parent chain, and we have to consider this cyclopentane as the substituent. That's why at the second position cyclohexane is cyclopentane is attached. That's why we have to treat this particular one as the side chain. And now at the second position, hyphen, here cyclopentyl, because we are actually we are naming this particular group only, not like H is not attached over here, correct? That's why we have to write cyclopentyl. YL should be there at the last. And what is the remaining over this? 6 carbon is there with saturation, correct? We have to write not cyclo. Here this is normal chain is there, means hexane. 2-cyclopentyl hexane is the name for this particular compound. Here we can see that the ring, what 6 carbon is there in this particular ring, and over the here only 4 carbon atom is there. That's why we have to name from this particular one. We have to number the ring, correct? That's why I will number like this: 4, 5, 6. At the one position, this what is this group called as? It is secondary carbon, correct? Secondary carbon, and here 4 carbon is there. That means secondary butyl group is attached at the position 1. That's why we have to write it as secondary like this: secondary, then hyphen, butyl, this butyl, then this particular group, that is cyclohexane. Like this we have to number. Then we'll move on to the next thing. Here also we can find that the ring contains more number of carbon atom compared to this side chain. That's why this one whole thing will become the side chain, and here the name has to start from here. Here you can see that we can give from here 1, 2, 3, 4 like that. But since double bond is there in this particular ring, we have to give the preference for double bond over single bond. Double bond will get the higher priority compared to single bond, correct? That's why we have to start numbering from here: 1, 2, 3, 4. At the fourth position, we have this whole substituent. That's why we have to write it in prefix. That's why here I will write, if we want to give the number for this particular group, we have to number from 1, 2, 3 like this. We should not give number from here 1, 2, 3 like that. Where we have to treat this particular group as a substituent, and which group is directly attached to this particular ring, we have to give the number 1. At the 1 position, chlorine is attached and methyl group is attached, and here propane is there. We have to name it as at the 4th position, 4 hyphen we have to write. And since we are naming this whole group, we have to open the parenthesis over here, and here 1 chloro is there, correct? That's why 1, and sorry, C should be caps over here. Here chloro, this is chloro. Then again here 1 position methyl is there, again hyphen 1 methyl, 1 methyl. What is this particular group called as? This is propyl, correct? That's why here methyl propyl. Again we have to close this because we already named this whole group, and here we have to name this cyclo. This is cyclo hex 1, because at the position 1 there is a double bond, correct? Here like this. This is the IUPAC nomenclature. Then we'll see the next molecule, which is this particular one. Here same thing. Here also double bond has to get the highest priority. Therefore numbering has to be done like this. At the 3rd position, nitro is there. That's why I will be writing as 3 nitro. What is this particular group? Cyclohexene. Here cyclohex 1-ene. This is the IUPAC nomenclature for this particular compound. Then we'll move on to the next thing, the rule 5. Suppose if side chain is there, this whatever the parent chain is there, it contains multiple bond or functional group. Here you can find it contains a multiple bond, that is double bond is there, and here functional group is there, which is aldehyde. then this particular group we have to treat as a parent chain, and whatever the ring is attached, it has to be treated as side chain. Here we have to give the number not to the ring but to the chain, correct? 1, 2, 3. At the third or the second position, there is a cyclohexyl ring. That's why we have to start naming it as 2 this group 2 cyclohexyl, correct? Since we are naming this particular group only, YL should be there at last. And what is this particular compound called as? This is propane is there and aldehyde is there. It is propanal, correct? This is the IUPAC nomenclature. Then we'll move on to the next thing. Here you can observe that I already said if the side chain contains a multiple bond, we have to give this particular group as a parent chain and this one as side chain. The same rule will follow over here, this particular compound also. And from where we have to give the number, either from this particular one or this one. Absolutely, from this particular carbon it has to start, because the double bond has to get the lowest priority. 1, 2, 3. Correct. At the third position there is a cyclopentyl ring. That's why I will write it as 3 cyclopentyl and here this propene, correct? Here prop 1 ene. This is the IUPAC nomenclature. Then we'll move on to the next thing. Okay. The sixth rule will tell that if some functional group is attached directly to the ring, suppose if this one is the ring and directly functional group is attached, then this particular functional group has to add the suffix over here, which is like this. If carboxylic acid is attached directly to the ring, the suffix carboxylic acid only has to be used. If suppose ester is there, the whole ring we have to name first, and afterwards we have to add carboxylate at the last. And acid halide is there, we have to add carbonyl halide. If amide is there, carboxamide. If nitrile is there, we have to add carbonitrile as the suffix. If aldehyde is there, carbaldehyde we have to use as suffix. It has to be noted down in order to name this particular compounds. Here it is cyclic compound is there, and one is carboxylic acid and another one is ketone is there. Actually we have to give the preference for carboxylic acid. That's why the numbering has to start from this particular carbon and here 2, correct? At the second position, this one has the what is that, subsidiary functional group, we have to take it as ketone. It has to be name in prefix. That's why we have to write it as 2 hyphen, and for ketones what is the prefix, that is oxo, correct? Here I have to write it as 2 oxo. This particular whole group we have to name here, that is cyclohexane. Here elision of E will not takes place in this particular one, as in the previous video also we discussed the same thing. Here also there is no elision of E. At the position 1 we have carboxylic acid. Here carboxylic acid. This is the IUPAC nomenclature. Here the carbon, sorry, C is small, lower caps is there. And here if we want to name this particular compound, we have to give priority for this particular functional group. That's why the numbering has to be done in like this: 1, 2, 3, 4, 5. This is cyclopentyl group is there. Here this methyl is there, we have to take it in prefix because it is a substituent. That's why we have to name it as, here from here I will start 2 methyl. 2 methyl is done, and this particular whole group we have to name, that is cyclopentyl. And what is this suffix we have to add in case of amides, that is at the position 1. Okay, here cyclopentyl, no cyclo, okay, here cyclopentane, there is no elision of E in this case, that's why cyclopentane, and here 1. and here what is the suffix for amide, that is carboxamide. Correct, like this we have to name. Here there is a little confusion that if only functional group which is directly attached, the prefixes what is their cyclopentyl we will use, but in this particular case we have to fully name it as cyclopentane without elision of e also has to be included in this particular case. Now we'll move on to the next thing, that is, if suppose in this case if ring contains a multiple bond and the side chain contain functional group, then ring is treated as a substituent, and this substituent and the compound is named as the derivative of the side chain. Here we have to give the number from 1, 2 and 3. Even though it contains a multiple bond, we have to give this whole group as the parent chain, and we have to treat this cyclopropene this particular group as side chain. That's why at the second position we have to name this substituent in prefix. That's why here 2, and we have to open the parenthesis here cycloprop. Here 2 is there. From here we have to name from, for ring we have to name like this 1, 2, 3 like that. Correct. Here prop, then again hyphen. At the second position we have this particular double bond. Correct. That's why here enyl. This particular word we didn't use in enyl group, and here prop, this particular one I am naming propan. This is propanol. Correct. That is the position 1 it is attached. That one also we have to name it as propan, and here 1 all. Here you can observe that at the second position we have this whole ring as a substituent. That's why we written it is in parenthesis over here 2 cycloprop 2 enyl. Correct. If we have only this particular group is there like this, we generally we will call it as cyclopropyl. Correct. Since here double bond is there, here enyl also we used in this particular case. Now we'll move on to the next thing, which is this particular one. Here, since the substituent, the ring does not contains any functional group, but it contains a multiple bond. And here in the side chain, we can observe that it contains carboxylic acid. Generally, carboxylic acid will get the highest priority, and it has to be treated as the main parent chain. That's why for this particular one, we have to number. Correct. From here only it has to start number 1, 2, 3, and here 4 is there. That's why this whole group is a substituent over here at the third position. That's why I will write it as 3 of here, like parenthesis we will open over here, and at the position 4 we have this particular methyl group. Correct. That's why here 4 methyl, 4 methyl. And what about this one? This is cyclohexenyl. Correct. At the position 2 we have to name it as cyclohex 2 enyl, 2 enyl. We have to close the bracket because we name this particular one, and over here propanoic acid is there. Just we have to write that one here, propanoic acid. This is the particular one. Suppose here at the fourth position, if OH group is there, just we have to name it as 4 hydroxy will come over here. Even if OH is there or aldehyde is there, generally we have to name this particular ring as side chain, because carboxylic acid has to be treated as highest priority. Then we'll move on to the next thing. Now only just I saw that here if OH is there, we have to write it as 4 hydroxy, because here carboxylic acid always we will get it in parent chain. That's why here 1, 2, 3 we have to name it as, and here just I will start naming this particular one also, and like this. At the third position we have to name this whole substituent. This substituent contains 4 hydroxy group. Correct. Over here I have to just write it like this 4, then H should be higher cap. Here hydroxy cyclohex, cyclohex 2 in aisle. Here this one is 2 in aisle again, and whatever this one, this is propanoic acid. Propanoic acid. This is the IUPAC nomenclature for this particular compound. Here two different functional group, even also if it is there, we have to give the priority for carboxylic acid. Then we'll move on to the next thing. Suppose if similar functional group is there in ring and also in side chain. In this case, what we have to do is, in this case, if both ring and side chain contains the same functional group, then the parent hydrocarbon decided on the basis of number of carbon in the ring as well as in the side chain. Here you can observe that it contains a 6 carbon and over here it contains only 3 carbon. That's why we have to name this particular ring as a parent chain and this one as side chain. That's why I have to start number from hydroxy functional group 1, 2, 3, 4, 5, 6 like this. And for this particular one, if I want to give number, I have to start from 1, 2, 3. This whole thing is a side chain over here. We have to write it in prefix. That's why here at the second position, this is the second carbon. 2 I have to write at first, and again I have to like parenthesis. And at the second position, there is hydroxy. That's why here 2 hydroxy, here 2 hydroxy. Then what is this particular group called as? This is propyl, since it contains 3 carbon. This is 2 hydroxy propyl. We named this particular one, that's why we are closing the parenthesis. This is cyclohexanol, correct, at the position 1. That's why I have to write it as cyclohexan 1 all. Here there is a elision of E, you can observe over here. In naming the alcohol, we have to just elision of E has to taken place, and afterward the position of this particular hydroxy group and then OL as a suffix for alcohol. Now we'll move on to the next thing. If it contains more than one cyclic ring, suppose here 3-membered ring is there, here also 3-membered ring is there, we have to give number for this particular chain 1, 2, 3 like that. At 1 and 3 position, there is cyclopropyl ring, correct? That's why there are 2. That's why I have to write it as 1, 3. Here dicyclopropyl, cyclopropyl. And what is this one? This is simply propane, correct? We can name like this. And suppose in the same way, if we want to name this particular one, here 1, 2, 3 is there. At same thing 1 and 3 there is dicyclohexyl ring. That's why you have to write dicyclohexyl. What is this particular one? It contains 3 carbon. That's why propane. Like this, we have to name the alicyclic compounds. I hope this particular video is helpful for you people. We'll meet on next upcoming topics. Thank you very much for watching.